Hi, good afternoon, everybody. Nice to have you here. My name is Kristin. I'm an MD at Nscale, and I'm very excited to be moderating this discussion. Now, before we get to know our panelists, just join me in zooming out just for a minute, because if you think about the last decade, we have really measured infrastructure using metrics that mostly mattered to engineers. Now, AI is changing all of that. Today, there is one metric that directly connects infrastructure to the end user, time to first token, or TTFT. Now, for those of you who don't know Nscale, just a couple of words on us. We are building the physical and digital foundation that enables AI at scale. And we are a vertically integrated AI hyperscaler that own and operate layers of that stack. Now, in this discussion, what we would like to focus on is very much connected to how we think about AI as an integrated system. Because performance can never be determined by a single layer in isolation. And that system is what Jensen Huang often refers to as the AI five-layer cake. You have energy, chips, infrastructure, models, and applications. And every layer depends on the one beneath it, and every layer impacts the experience and the performance on the layer above it. Now we're fortunate to have two leaders with us that are defining those layers of the cake. So let's get to meet our panelists. Rod, let's start with you. Can you say a few words around your role at NVIDIA and also how NVIDIA works with partners like Nscale and others within the five-layer cake?
Sure. So I'm Rod Evans. I'm the European Vice President for AI Cloud Infrastructure at NVIDIA. And my whole mission is to make sure that we can provide cloud services out there to all of our customers globally. So working with people like VAST on the infrastructure level for storage and data, and with Nscale as one of our leading service providers, helps to build up some of those layers of certainly on the bottom three layers of the five-layer cake.
Jeff, over to you, same to you. Could you introduce what you do at VAST and also how VAST works with partners within the five-layer cake?
Sure. So I'm Jeff Denworth. I'm a co-founder of VAST Data. VAST has built the data services layer that's used by most of the world's largest AI clouds today. The company powers somewhere between 4 to 5 million GPUs around the world. Largely made by the NVIDIA Corporation. And yeah, we've been helping organizations build very, very scalable services platforms. And if you think about the five-layer cake, you have energy, and you have processors, and you have the compute layer, then you have models and applications. And VAST sits at the compute layer, building basically a platform designed for storage and database services, as well as a compute runtime that's used for things like RAG pipelines and agentic pipelines that customers can build on top of NVIDIA hardware using the models of their choice. So we're the GUI center of the cake, I think, that a lot of people really like to use.
Good way of putting it, I like that.
GUI.
GUI, yeah.
We also have a GUI.
Everybody got that. Thank you. So time to first token, as we hear, and we heard that earlier today as well, is suddenly everywhere. And it's impacted by the layers of the cake that we just touched upon. So if we start with you, Rod, what has actually changed? Why is time to first token the metric that everybody's talking about and not just focusing on cost per token, utilization, and return on investment?
So if you look at the sheer investment required to bring these things to marketplace in terms of the data center, the storage, the GPUs, everything that goes with it, then you really need to make sure you're making that infrastructure actually create things that have value, tokens. So it really becomes super important now if you're adding a 20 megawatt, 10,000 GPU system, you're a shade under $2 billion to put that infrastructure in place. Now, when you've got that sort of investment set there, I don't think anybody can sit there with $2 billion not earning any money. So the critical thing you have to do is make sure you get this integrated as quickly as possible, and you think of the whole picture. So it isn't just about the GPU. It isn't just about the storage. It isn't just about any aspect of it. It's a really tight integration between all the layers to make sure you're maximizing that investment to get the return back to your business or businesses as quickly as possible.
It's all happening in sync, in other words.
Absolutely, and it's becoming more and more that way as we start to build systems now where you have a lot of GPU sharing with memory between the GPUs. It becomes super important that you have a well thought through infrastructure to make it happen.
So if you want to build on that, Jeff, from your vantage point, what do you think has changed over the last, let's say, 12 to 24 months?
First of all, I think the economics have changed, right? You know, if I go back 2 years ago, people were selling GPU by the hour, and now if you can sell tokens as a service, you can basically take that same asset and sell it for 2 times as much, right? And so then that takes you down a path of building inference services that ultimately can drive a much better margin profile for organizations. And you know, to me, NVIDIA is a very, a very exotic animal in that, you know, there are things that Jensen pushes that are far in advance of what the market actually sees. And he's been talking about token factories for like three years now. And now we're actually seeing them get built where service providers are only selling tokens. And the interesting thing about his pursuits and his thrust into the market is he's pushing for absolute lowest costs of token delivery, and that requires full stack optimization all the way from, you know, how the power gets deployed up to applications get built on models. And NVIDIA is an amazing organization in my book just because they're way ahead of the market and always building for the next 2 to 3 years of demand out. And that just involves depressing token costs while also, you know, giving the best possible service experience. And so, yeah, you got to get costs down, but the way you get costs down is by bringing the time to first token down. You just need less, you have less machinery waiting for an inference operation to start and then complete.
So as we're hearing, it's a whole stack metric, and Rod, the floor is set by compute. So if we take the latest updates from NVIDIA sides, what is so important about those updates, and what do you actually change at the hardware level? And how does those changes actually affect how latency and ultimately throughput utilization and cost per token are impacted?
So if you look at the latest announcement NVIDIA's announced, we've announced improvements all the way along the stack. From our new Vera Rubin generation, we've got dedicated product for inferencing, and the requirements are also changing. If you look at large language model training or large language models, most of the mathematical operations are matrix mathematics. Now, matrix mathematics just needs lots of raw grunt to make it work, raw horsepower, raw flops. When you get down to inferencing, it's much more into looking in terms of memory bandwidth. And you get different types of architectures. So we've launched a new architecture that brings in a CPU layer. We bring in an inferencing, dedicated inferencing chip with the LPX platform. We have Vera Rubin providing the full stack for the large horsepower type applications. And we've done integration improvements all the way through the stack. Got new networking technology. With our next generation system, there's no cables in the back between all the GPUs. It's cableless because that's much more efficient and requires less infrastructure to make it work. But more significantly about all of this is we're really trying to build out this concept of the token factory and build it out there so that you have every single aspect of it is tightly integrated with the applications, the models, the whole 9 yards to make it into the most efficient system you can get in terms of getting that token out there much quicker.
I think it's also fair to say that storage is now being built into the computer as well. And maybe you want to expand on that?
Yeah, adding storage into the layer is absolutely fundamental because if your GPU is sitting there idle, it's not doing any work. And the biggest inhibiting factor today on getting GPU systems and AI systems into production is typically the data infrastructure. And by that, do I have data in the right format? Have I cleansed it the right way? Can I get the right performance to keep the GPUs busy? And it's really fundamental that you get a really very well-architected, referenceable data platform to make that work, such as provided by VAST Data, which is very, very heavily integrated with the architecture we're putting forward.
I wasn't looking for a VAST.
It's okay.
No, what I was saying is now you have, you were talking about the memory hierarchy changing. Yes. And inference creating memory bandwidth problems. So the definitions of memory are also changing as people deal with, Kevin Deerling calls it big C and little c.
Absolutely.
Right? Little c is the context used by KV caching, yep, which then requires you to have some sort of substrate between your decode and your prefill processors for inference workloads, and then you have a separate set of systems for like context that an agent might need just to kind of understand who they're working with. But But NVIDIA is building these storage systems into the core computer through technologies like CMX that, that we didn't expect to see even 2 years ago.
Absolutely. You know, Jeff, I should give Jeff a job. He does a better job in selling NVIDIA than I do, so it's great.
That's true. No, I'm kidding.
So, Jeff, you're actually saying that in many ways, the latest developments is leading us to where storage that maybe traditionally was looked upon as sort of a silent bottleneck is now actually becoming a massive multiplier.
I think so one of the keys to building robust and trusted infrastructure is following the reference architectures that organizations like NVIDIA build. And now the definitions of these systems is changing fundamentally where they're becoming data computers. And they're integrating storage systems natively into the core networks of these systems. And actually NVIDIA is building the hardware too, so it's very, very tightly defined as the memory hierarchy gets turned upside down by inference.
Selling NVIDIA again.
Absolutely. I can't add anything to that. He's better than me.
Well, sell some VAST.
So you're both describing a world where the layers, meaning compute, data, deployment, have to be designed together, but not necessarily bolted together. Now, the most enterprises that all three of us work with, they're not necessarily starting from scratch. I mean, these enterprises have their existing infrastructure, they have their existing vendors, they have their existing contracts. So how do you actually help them improve the key metrics around AI economics without doing something very painful, which is starting from scratch?
So one of the things we recommend to people is don't just try to recreate or change or replace your application. Look at simple ways you can augment the applications and layers you already have by adding new functionality. And a good example of that might be if you have a service desk application providing customer service, why don't you just add some AI agents that can look at the questions and calls that are in the queue and suggest responses and how to add that into the API. So when your agent actually gets to that in the queue, they've got a lot of data pre-fetched for them ready to go. Now that's a simple way to add an AI expertise into an existing application area. And we like to work closely with customers to understand what is the objectives you want to get out of the AI project you're trying to do. How are you going to measure success? We did a roundtable earlier today, and some of the senior executives were there saying, like, right now we're seeing huge benefits from agentic AI. It's really good benefits to everything, but what we really got to know now to is how is that improving the bottom line? So we need to help people really understand what are the objectives of what you're trying to do by bringing in these new AI systems, and what is going to be the return to the bottom line of your company when you do that. So I think really thinking through how this is going to integrate with your existing systems, how you augment the existing applications you have, how do you make sure that the systems can actually use the data that you've already got that may be in a different format that you might need to reformat to make the AI application use it better, but really to think through in a wider context what benefits you're going to get out of deploying these solutions.
Same question to you, Jeff.
I don't think we care. And we have the luxury of not caring. But if I have to sit in front of a 200-year-old bank and explain to them why they need AI and that they're going to have to go through a 15-year process with 17 different systems integrators, then it's just a complete waste of everybody's time. While the market is growing, exponentially, and so from our perspective, we don't suffer AI tourists well. And we don't spend any time with them just because there's more than enough to do in the world. And what we see is that there's an entirely new stack emerging that is throwing away most of the conventional legacy IT stack. And so for us to sit there and try to retrofit that into this modern era is just a complete waste of resources and a waste of the good investment dollars that our investors give us. So we focus on the new stack, the new data. And I think our growth is indicative of the fact that that's all you need to do in order to build a very successful business. And so not everybody's going to come along for the ride, and that's the price of disruption.
And what happens to those who don't come along for the ride?
We won't be talking about them in the future. We're really not talking about them now, so who cares?
So last question to both of you, because I know there's a lot of executives in the room. and spending a couple of days here now in Paris at Race and getting a lot of inspiration and talking to the startups and the scale-ups and the established players that are present here. If you could give one piece of advice to any of these executives on what should they be doing different from Monday onwards or from tomorrow onwards, what would that be? What are we not good enough at thinking about that we should be thinking about?
So I have a great piece of advice to the executives in the room. A lot of the executives make decisions on going for an AI system, and they go and make the investment available for it, but then they don't use it. So they're not leading by example. So my advice to everybody here is get to learn and know the technology and see what it can give you. I got to be honest, I took a long time getting myself into this layer because I didn't think I had the time to go and learn it. But then what I quickly found is by deploying agent-based AI, I actually got to see in real firsthand what it actually can do. How it can actually improve my efficiency, how it can improve the efficiency of my team. And I think that enables you to look at this thing in a completely different way than you would do if you just delegate the decision to somebody else on what to buy. If you delegate it without understanding and owning it, then really you're delegating everything. You're delegating your future to somebody else's architecture and roadmap rather than being a part of building the future with your employees and your company. So please go out there and embrace the technology. And I really wish executives can go out there and start to see what productivity they can gain just from using the technology themselves.
I think it's, for organizations that are outside the AI labs, I think it's still regarded as research or speculative bets that get made with respect to AI. The problem with speculation is that nobody can commit themselves to it, so it becomes something that you want to hedge against. And hedge strategies ultimately always mean that there's counterparties betting against you being successful, and that just is not going to be the way that people can successfully operate in this market, given the pace of change. And so my first advice is to organizations that are contemplating making serious investments to have the business primarily be the owner and empower that owner to make decisions unilaterally across several divisions within an organization. Otherwise, somebody will block progress. Number two is, when it comes time to build, either within a very professional cloud like Nscale or building your own infrastructure, follow the best practices, because everybody likes to invent. Engineers like to engineer, and this technology is so difficult that there's just not a lot of time for experimentation and learning, and we just need to move.
I hope everybody took notes of that. Thank you very much to both Jeff and Rod. And for those of you who would like to continue this conversation, I do encourage you to come over to our Nscale booth. We're going to be here throughout the event together with our partners, NVIDIA and VAST, and would love to welcome you there. So please thank you, join me in thanking the panelists and enjoy the show.